Okay, hello everybody. Today I'll be presenting my YouTube analytics project. It's MichaelBuss, by the way. The goal of this project was to take the raw dataset containing YouTube channel performance metrics, clean the data, analyze growth trends, visualize key relationships, and then build a predictive model to forecast future channel performance. The project follows the complete data analytics workflow: data cleaning, exploratory data analysis, visualization, predictive modeling, and model uh, evaluation. So first we upload all of our files. We then determine what the missing value counts are, what the duplicate rows are that are missing. As with most real-world data sets, the initial data contained issues that needed to be addressed before analysis could begin. The first step was identifying the missing values and duplicate records. I used pandas functions to count missing data and detect duplicate rows. Once these issues were identified, I removed duplicate records and dropped rows containing the missing values. After cleaning, I verified that the dataset contained no remaining duplicates or missing entries. This ensured that all later calculations and visualizations were based on reliable data. And then we moved into the exploratory data analysis. With a clean data set prepared, that's where we were. I calculated several key metrics, including highest number of views, lowest number of views, average views, highest number of likes, highest watch time. These statistics provided an overall understanding of channel performance and established a baseline before moving into visualization. The results showed a clear upward trend in channel growth over the observed period. Then we moved on to visualization and trend analysis. So to better understand the data, I created several visualizations. The first chart is a scatter plot showing day versus views. The chart reveals a strong positive relationship, indicating that view counts consistently increase over time. The second chart is a line graph of day versus views. This chart demonstrates a positive correlation between the audience traffic and engagement. As videos receive more views, they also tend to receive more likes. This chart demonstrates a positive correlation between... reading the same part again. Finally, the horizontal bar chart... no. This is my other... One more scatter plot. I didn't like this one. Views versus likes scatter plot. Let's move on. So, this one it maps the audience engagement against channel traffic. While it looks like an unrefined cluster of points stretching upward, the scattering shows a clear positive trend, confirming that as the video accumulates more views, it predictably gains a higher volume of likes. And then finally, we'll move on to the horizontal bar chart. It displays daily engagement performance, making it easy to compare activity levels across the entire tracking period. So the number of likes over the number of days. 1 day in, lower likes. 30 days in, the most amount of likes, yes. And then we move on to the linear progression model. So after analyzing historical performance, I built a linear regression model to forecast future channel growth. The model uses the day number as the independent variable and total views as the dependent variable. After training the model on the historical data, I generated predictions for future dates, specifically 40, 45, and 50. The model predicted continued growth consistent with the trend observed in the historical data. So, and then I'm scrolling ahead of where I need to be. So, and then the next section is model evaluation. To evaluate the quality of the model, I calculated the R value. Sorry. The model achieved an R-squared value of approximately close to 0.99, but it was actually 0.9896. An R-squared value this close to 1 indicates that the model explains nearly all of the variation in the dataset, suggesting an extremely strong linear relationship between time and view count. The visualization of the regression line further confirms this, as the prediction line closely follows the historical data points. And then lastly, it is the prediction versus reality. To test the model's effectiveness, I compared the predicted value for day 40 against actual future data. The model predicted approximately 8,202 views, while the actual result was 8,443 views. This produced an error margin of only 2.85%. Considering the simplicity of the model, this level of accuracy demonstrates that linear regression can be highly effective for short-term forecasting when historical growth patterns are stable and consistent. So in conclusion, this project demonstrated the full analytics process from raw data to actionable insights. I successfully cleaned and prepared the dataset, explored key performance metrics, visualized growth trends, built a predictive model, and evaluated its accuracy against real-world results. The results showed consistent channel growth and confirmed that linear regression can provide reliable short-term forecasts when historical trends remain stable. Thank you for your time, and I welcome any questions. And then there was the set of questions here, but that's too much more reading. Okay, thank you.